Hi there, everyone. Welcome back to another week of Algebra 2. This week we're going to be talking about solving systems utilizing the matrix multiplication that we talked about last week. We're going to go through some simpler examples and then one more complicated. And you guys can kind of get you guys can kind of see some of the process that you're going to be doing as you go through these, okay? So especially pay attention to some of the conceptual stuff that we talk about, some of the thinking that you need to do to kind of see how these are set up and why we're using them and how they're used, okay? So first thing that's going to be really important is we're going to be finding what's called the inverse of a matrix. And the way that we're going to find the inverse, is by augmenting with an identity matrix and then using a row operations to turn the original matrix into itself an identity matrix, and what's going to happen is we'll get the inverse. That sounds a lot more complicated than it's actually going to be. We'll see in a moment what that actually looks like and how we do that. What's cool about the inverse is it's going to behave a lot like an inverse would in normal multiplication, right? When we multiply something by the inverse, we get the identity. That same thing is going to be true about the inverse we find here. So how do we go ahead and we do that? Here's an example of a matrix. I'm going to find its inverse. The way I do that is by augmenting it with an identity matrix. So I'm going to write out my matrix here. And then I'm going to go ahead and put an identity matrix over here. So 1, 0, 0, 1. Remember, the identity matrix has ones down the diagonal and then zeros everywhere else. Kind of get that triangle of zeros that happens as you go. And then what I want to do is I basically want to take this matrix and turn it into an identity matrix. And whatever I do over here to make this an identity matrix, same thing is going to happen over here. And that's going to result in this side over here showing me what the inverse matrix would be. So I'm going to go ahead and do that over here. So let's see. I'm going to start by making this row turn into a 1. I'm going to do that by doing negative 1/3 times row 1. So I'm going to have a 1, a negative 4/3. Over here, I'm going to have negative 1/3 and 0. And then this row is going to stay the same. And then I'm going to do negative 2 row 1 plus row 2 in order to make this cancel out. So let's see if we do that. Our top row is going to stay the same. And in the bottom row, we're going to get a 0 here. Negative 2 times this is going to be 8/3 plus negative 1 will be 5/3, positive 5/3. And then up here, we're going to have 2/3 plus 0. So we'll get a 2/3 here. And then we're going to put just 1 here. Okay. And then now I want to turn this into a 1. So we're going to do 3 over 5 times row 2 to turn this into a 1. Top row is going to stay the same. Bottom row, I'm going to have a 0. 3/5 times 5/3 will be 1. 3/5 times 2/3, the 3's will cancel and I'll get 2/5. And then 3/5 will go here. And then I'm going to do 4/3 row 2 plus row 1. Okay, and so my final matrix I'm going to write down here. Let's see, we're still going to have 1 here. We're going to have a 0 here. Over here, I'm going to have 4/3 times 2/5, which will be 8/15, plus negative 1/3, which is negative 3/15. So it's going to be 5/15 or a third. Let me make sure I did that right. So 4/3 is 8/15. 8/15, and this would be negative 3. No, I did not do that right. Hold on, let's fix this. So if I'm doing 4/3 times this, I'm going to get 8/15. And then up here, I'm going to have negative, I want to make this a common denominator, so I'll multiply by 5. So negative 5/15, which if I add these together, I'll get 3/15, which is 1/5. So 1/5 is going to go here. Okay, so sorry about that, 1/5. And then over here, I'm going to have 4/3 times 3/5, which those are canceled. I'm going to get 4/5 plus 0, so I'll get 4/5. And then down here, the bottom row stays the same. Now, when I look at this, what I'm going to find is that this matrix over here, this piece right here, is going to be my inverse matrix. So my inverse matrix for this one right there is 1/5, 4/5, 2/5, and 3/5. And that would be the inverse matrix for this matrix right here. Now you might be asking yourself, Mr. Guy, okay, we found an inverse matrix. What is the point of that? How is that helpful? Well, what we're going to do is we're actually going to be using the inverse to solve this equation that we have set up here. So you'll notice that matrix that we had back here, lets me go back, okay, -3, 4, 2, -1, that matches up with the coefficients that we have here. And in fact, I can actually rewrite this system into a version that involves a matrix, okay, to make it so that I can use a matrix to solve it. Now, what that would look like would be something like this. We'd have -3, 4, 2, and -1. There's a matrix. We would have a matrix that would involve our variables, so x and y, they'd be our variable matrix, and then we'd say that that would equal our answer matrix over here, which would be 5 and -10. And this is kind of setting up almost a matrix multiplication problem that I can then kind of use conceptually to solve this problem. If you notice, if you were to do matrix multiplication here, -3 times x, 4 times y, oh, look, you would get this equation. If you multiply this, you would get this equation. That's where this is coming from. We're setting it up as a matrix. Now, I want you to think of a normal multiplication problem that you would solve. So let's say, for example, we just call this A times B equals C, and C being our answers over there. Our goal is to solve for B, right? We want to figure out what B is. Well, how would I solve this? Well, if we think of normal multiplication, we would go ahead and we divide both sides by A in order to solve it. And we'd say, okay, B equals C divided by A, and that's how we'd solve for B. So if I know C and A, I can go ahead and I can solve that. The problem with that is that that's for a very specific example multiplication, but conceptually, why are we allowed to do that? Why are we allowed to divide by A and have that solve the problem for us? Well, it all comes back to something we did in the very beginning of algebra, which is talk about inverses, okay? Inverses undo this. They allow us to do these things. So for example, I'm allowed to multiply by the inverse. And if you remember, matrix multiplication has to be done on the same side because it is different if you flip the side, it's not commutative. But if I multiply by the inverse, that's going to make this cancel out, and that's going to give me my answer, which is going to be basically that A inverse times C is going to give me the answer to my problem. Okay, well, why is it helpful? Well, we actually just found the inverse for this. We know our solution matrix. Those are like the two things we know. So I can solve for x and y simply by doing A inverse times C. So if I wanted to solve for that, and we'll do this over here, I know that if I multiply my A inverse, which I found in the previous slide, so if we go back and look, our A inverse was 1/5, 4/5, 2/5, 3/5. So if I do 1/5, 4/5, let's make sure I don't mess this up, 1/5, 4/5, sounds like a Dr. Seuss book, 2/5, and 3/5, and I multiply that by the matrix 5, 10, 5, -10. Okay, if I multiply these, then what that's going to allow me to do is it's actually going to give me the answer for what x and y are supposed to be. And you'll see this is a 2 by 2, and I'm multiplying it by a 2 by 1. My resulting matrix is going to be a 2 by 1, which will match up with what x and y are. So let's see what happens here. So if I go ahead and I do 1/5 times 5, I'm going to get 1. And then 4/5 times -10, I'm going to get -8. Add those together, I will get -7. And then for the other one, I'm going to do 2/5 times 5. That'll give me 2. We'll do 3/5 times -10. That'll give me -6, which will get me -4. The answer to my problem is going to be this matrix right here that I just got, -7, -4. And if you look, based off what we see here, B is going to equal this. So my B was x, y, and then my A inverse C is going to be -7, -4, which is going to be the answer to this problem. I solve it just by doing matrix multiplication. And we can check that to make sure that it works. So -7 times 2 will be -14, plus 4 is -10. Seems to work there. Up here in the top, we're going to get 21 plus -16, which is 5. So it does work. There is our answer. So just to review how I did that, I went ahead and I found the inverse of this matrix. I set this up as a matrix multiplication, found the inverse of this, multiplied it then by this matrix over here, and that gave me the answer I was looking for. Now, with this equation this simple, you might say, Mr. Guy, it seems like a really, really long-winded way to get the answer. Why would I do that work? Well, we're going to be practicing this with the 3 variable systems we've been talking about before. I'm going to give you guys a little more practice on the 2 variable, and then we'll do some 3 variable ones. But I want you to think a little bit about how you could extrapolate this out further. The reason why this process exists and why it's really helpful is, what if I have a system that's not even just 3 equations and 3 variables? What if it has 4 equations and 4 variables, or 5 and 5, or 6 and 6, on and on and on and on? You know, in the real world, a lot of the times the systems we're talking about will have a lot of different variables that are affected that we're looking at. Think about if you run a restaurant and you're trying to maximize your profits, and you can set up a system of equations to try to do that. You have a lot of different things that are going to factor into what makes you profitable and what doesn't. It might be you have an equation that represents the expenses of what you're buying. You might have an equation that represents the pay you're giving your employees. You might have a equation that represents your rent, an equation that represents how much money you make, so on and so forth. And if you're trying to solve that system to figure out how to maximize your profits and what you're doing, that can end up being 10, 20, 30 variables and 30 equations that nobody would really want to solve. But we could use this same process to solve it in a much simpler manner than if we were doing it another way. Also, we can eventually get computers to help us do this as well, but this is sort of the process behind it. I'm going to stop the video here. I want you guys to go ahead and try some of the 2 variable ones, and then you'll see there's going to be another video that'll kind of walk you through a 3 variable example to show you kind of a very similar process, but just give you an idea of what that example would look like.